This is Distinction Learning Center, the light of education. Our tutorial for today is still statistics in details. Statistics in details, in which we are moving to the next section, which is basic statistics term. Basic statistics term. Now, we have many terms in statistics, in which some of them are listed in this particular section, in which we are going to explain it one by one. Now, the first term is called what? Class interval. It's called class interval. What is class interval? Class interval is a symbol defining a class, which is what? E.g., 60 to 62. It's called what? Class interval. That is a situation whereby you see this particular expression inside statistics. It's called what? Class interval. It's called class interval. Now, the end numbers of 60 and 62 are called class limit. That is, if you want to express it, if you don't want to call it together like this, if you want to call this only 60, if you want to call this 60, so you will not call it lower class interval. Instead, you call it what? Class limit. That is lower class limit. You will call it what? Lower class limit. But if you want to pronounce this one, it will be what? Upper class limit. It will be what? Upper class limit. So this will be what? Upper class limit. That means this 60 will be lower class limit and this 62 is what? Upper class limit. But if you want to call it together like this, like 60 to 62, so you will call it what? Class interval. So that is what they are trying to explain in that section. Let's now move to the second term, which is what? Class boundary. Now here, it says the class boundary are obtained by adding the upper limit of one class interval to the lower limit of the next higher class interval and dividing by 2. Now, what they are trying to explain here is that your class boundary, that is class boundary, can be obtained by adding the upper class limit of one class interval to the lower class limit of the next higher class interval. Now, what are they trying to say? You know, here we've explained what class interval is. Now, let's use this particular expression as an example. Now, we are given something like this as our class interval, 60 to what? 62. 60 to 62. Now, if you want to write the next class interval, it will be 63 to 65. And the next one was 66 to 68. So that means the class size will be what? 60, 61, 62. So that means our class size here is 3. So we are coming to that. So our class size is what? Is 63. Is 3. Now, from this particular class interval, you know this is called what? Class interval. This is called class interval. It's called class interval. Now, from this particular class interval, we want to generate our what? Our class boundary. We want to generate our what? Our class boundary. Now, how can we get our class boundary? Now, from the explanation above here, they say the class boundary are obtained by adding the upper limit of one class interval to the lower limit of the next higher class interval and dividing it by 2. Now, what we are going to do is that if you want to get the lower class boundary of this particular 60, what are you going to do? You know the preceding class interval of this particular class will be what? 59. That is 59. That is 57 to 59. So it was 57 to 59. So that means if you want to get the lower class boundary of this 60, what are you going to do? You will add this 60 plus this 50 and plus this 59. That is 60 plus 59 divided by 2. That means what? 60 plus 59. 60 plus 59 divided by 2. So that means our 60 plus 59 will be what? Now 60 plus 59 will be, I think that would be 119. So that would be 119. 119. Abi? So now once we have 119, so that means this one will be what? 119. 119 divided by 2. 119 divided by 2. That means 2 here, 1, 2 in 11, that is 5. And 2 in 19, that is what? 9. So point what? Point 5. So that means our class boundary here will be what? 59.5. So that means our lower class boundary here will be 59.5. So that means 59.5 will be this one. 59.5 minus our upper class boundary. That means you are going to add this one to this one and divide it by 2. You add 62 to 63 and divide it by 2. So that will be what? 62 plus 63. Now 62 plus 63 divided by 2, and that will give you what? That will give you 125. 125. Now 125 divided by 2 will give you what? That is 2 here 1, 2 in 12, 6, and 2 in 5, 2. That is 62.5. So that means our upper class boundary of this one will be what? 62.5. 62.5. So that is how you are going to look for the second class interval and the third class interval. So now if you want to look for the class boundary of the second class interval, so that means for you to get this one, so for your lower class interval, so it will be what? This 63 plus 62 divided by 2, that one also will still give you what? 62.5 is because we've done it before, so it will still give you 62.5. That is, we bring this one down. So if you want to get this one, so it's what? 65 plus what? 66. That is what? 65 plus 66. 65 plus 66 divided by 2. 65 plus 60 divided by 2. So that will now give you what? I think that will give you 131. 131 divided by 2. Now 2 here, 1, 2 in 13, that is 6. Remain what? 1. 2 in 11, that is 5. So point what? Point 5. So that means this will be what? 65 point what? 65.5. 65.5. So that means that is how we derive our what? Class boundary. So that is what this particular expression here is trying to explain. So that is what it's trying to explain here. So do you understand? Now let's now move to the third term. Let's move to the third term. Now the third term here states that class width. Class width. Now What's the meaning of class width? Our class width here is also known as what? Class size. They say the size or width of a class interval is the difference between the lower and upper class boundary and is also referred to as the class width, class size, or class length, That is the difference between the lower class boundary and what? And the upper class boundary. So it's known as what? As our class width. We have 62.5 here before for our class boundary. So that means if you want to look for your class width, what are you going to do? That is the difference between your upper class boundary, which is 62.5, and what? And 59.5. So if you minus it, it will give you what? It will give you 5 minus 5, that is 0.2 minus 9, that is 12 minus 9. 12 minus 9 is what? That is 3. And this 5 minus 5, that is 0. That is what? 3.0. So that means your class width is what? Is 3. So that means our class size is what? 3. So our class size or class width is what? Is 3. So that is what that one is trying to explain there. So that is what it's trying to explain there. So do you understand? Now that is that. So that is class width or class size. Now the next one is what? Class mark. Class mark. Now class mark means is the midpoint of the class interval and is obtained by adding the lower and upper class limit and dividing by 2. The class mark is also called class midpoint. Now what are they trying to say there? That is, they will say that what? You are going to add the lower class interval with what? With the upper class interval and divide it by 2. That is the lower class limit. The lower and upper class limit will be added together and divided by 2. Now this is our what? Lower class limit, and this is our what? Upper class limit. So that means we are going to add it together and divide it by 2. So that means we add 60 plus 62. 60 plus 62 and divide it by what? Divide it by 2. Divide it by 2. So now if we divide this by 2, it was 60 plus 62 was 122. 122 divided by 2, that is what? 61. So that means the midpoint of this now, the midpoint of this class interval will be what? Will be 61. And the midpoint of the second class interval, so that was 63 plus 65. 63 plus 65 divided by 2. Divided by 2. So that would be what? 63 plus 65 would what? 128. 128. Now 128 divided by 2 will give you what? 2 in 12, that is 6, and 2 in 8, that is 4. So that means this one will be what? 64. And also if we do this one, it will give you, I think it's going to give you 67. That is 63 plus 68. 63 plus 68. 63 plus 68 will give you what? Divided by 2. Now 63 plus 68 will give you 8 plus 6 is what? Is 14. That is 4. Even the 1. And 6 plus 6, that is 12. Plus 1, that is 138. 138 divided by 2. Divided by 2, that is 2 in 13, that is 6. Even the what? With the 1. And 2 in 14, that is 7. So that means this one will give us what? 67. So that means our midpoint here will be what? Will be 61, 64, 67. So do you understand how we arrive to the midpoint? So that's good. Now let's now proceed to the next term. Let's proceed to the next term, which is what? Frequency. What is frequency? A frequency is the number of time a value of the data occur. Frequency is the number of time a value of what? Of the data occur. What they are trying to explain there is that you can be given different data. For example, you can be given 2, 3, you can be given 2, 3, 2, 5, 4, 3. Now, this is an ungrouped data. You can be given something like this. Now, if you want to arrange it in a frequency table, so that means, what are you going to do? You will draw a line like this and do it like this. So, this particular numbers here represents a specific term. Are you getting it? So, it can be marks of what? Of students. It can be marks of students. So, you can also call it what? X. Let's call it X. Now, the lowest number here is what? Is 2. Now, how many times does 2 appear here in this particular data? So that means we have 1 and we have what? 2. So that means 2 appear in what? In 2 times. So that means your frequency of 2 will be what? Will be 2. And how many times does 3 appear here? That is 2 times. That is 1, 2. Abi? So that means 3 appear 2 times. So that means your frequency of 3 is what? Is 2. And also, how many times does 4 appear? That is 4 appear what? 1 time. 1 time. So, and how many times does 5 appear? So 5 appear 1 time too. 1 time. So that means, so this is your what? Frequency. So this is how we construct our what? Our frequency. So that means your frequency is what? 2, 2, 1, 1. So, do you understand? So that's the meaning of what we call frequency. So that is the meaning of frequency. Now, let's now move to the next term. So, we've done frequency. Now, let's move to relative frequency. Now, relative frequency is the ratio of the number of times a value of the data occur in the set of all outcomes to the total number of outcomes. To find the relative frequency, divide each frequency by the total number of students in the sample. By the total number of students in the. So, to find our relative frequency, so what are we going to do there? Based on the explanation, divide each frequency by the total number of students. Now, let's make use of the previous example that we have done. Let's make use of the previous example, or let's work on another example. Let's say these are given data. I go to 2, 3, 2, 4, 3, and 5, and then 5, and 5. Now, this particular data, we want to find the frequency. We want to find the relative frequency. So, before you can get the relative frequency, you will first need to generate your frequency table first. You will generate your frequency table. If you recollect, what the first thing that we are going to do, you first write your x here, Abi? And we have, how many number do we have there? We have 2, we have 3, we have 4, and we have what? 5. So, for you to now get your frequency, how are you going to do it? That means, how many 2 do we have in the group data there? That is 1, 2. So that means we have 2, 2, Zabi. So that means we have 2. So how many 3 do we have? 1, 2. So that means we have 2, 3. That is 2. And how many 4 do we have? We have 1. How many 5 do we have? That is 1. So that means this is what? Frequency. Now your relative frequency, which is RF, which we are going to short to RF. So your relative frequency will be what? Now, based on the explanation above, they said divide each frequency by the total number of what? Of the students in the sample. Relative frequency will now be what? Will now be your frequency divided by number. That is frequency divided by what? Number. Now, the first frequency here is what? Is 2. Abi? Is 2. So that means you write 2. Divided by the total number that we have. No. 1, 2, 3, 4, 5, 6. So that is 6. Abi? So that means 2 over 6. That is 2 here, 1. 2 is 6. That is 3. And 1 divided by 3 is what? So is 0.3. Is 0.3. Now, that is what we call relative frequency. So that means this one will be what? 0.3. This will be 0.3. Now, if you want to do the relative frequency of the second frequency here, so that is what? Is still the same thing. That is 2 divided by 6, which will give you what? 0.3. And the third one, which is frequency of 1, so that means relative frequency of this will give you what? We give you frequency over number. Frequency over number equal to 1. That is, this one is what? 1, Abi? 1 over what? Over 6. That is the total number of what? Of frequency that we have. 1 over 6. Which will give you what? 0.16. So 0.16. So which we can approximate as what? 0.2. 0.2. Which we can approximate to 0.2. And also this one also should be what? 0.2. So this is what we call what? Relative frequency. The relative frequency. So that is that about that. Now the next one is now what? Is cumulative frequency. Cumulative frequency. Now, what is cumulative frequency? It is the sum of a frequency of the particular class to the frequency of the class before it. Now, what are they trying to say there? What they are trying to say is that is the sum of the previous frequency to the sum of the next frequency. Now, if you look at this particular data here, you see that our frequency table is there, which is 2211. Now, your cumulative frequency will now be what? So, if you want to look for your cumulative frequency, that is the first number under the frequency here is what? Is 2. So, you write that one out first. So, the first number of the frequency, you will write it out first. You now add this number to the next frequency, which is 2. So, that means you just say 2 plus this 2 will give you what? 4. So that means the next number will be what? Will be 4. Are you getting it? Now, you will now add this 4 to the next number of the frequency, which is what? 4 plus 1. That will be what? 5. and also add it to another number here, which is what? 5 plus 1, which is 6. So this is what we call what? Cumulative frequency. So this is all about the basic statistics term that we are able to explain in this particular platform. So try to go through it, put more effort on it. I still remain CMAID from Distinction Learning.